Let's solve part 3, problem 2 of the 27th Philippine Math Olympiad qualifying stage. Alright, so for this problem, I'm assuming that you already went over the entire problem. I'll not be reading this one since this is very long. So I'll just go directly with the conditions and draw the figure. I might be jumping from one statement to another as I find it more convenient in drawing the figure. Alright, so according to statement number 1, or the first statement, there's a triangle ABC, and on side BC there is point x sub 1 such that angle AX sub 1C is equal to 120 degrees. So let's draw that one. Now I'll be identifying some obvious angles here because most of the time if we identify obvious parts, obvious measurements in the diagram, this leads to a very important connection of some other parts of the diagram. So obviously, angle AX sub 1B measures 60 degrees. Now, if you look at the third statement, it says the ratio of x sub 1A, x sub 1B, and x sub 1C is 1 is to 3 is to 1. This means that triangle AX sub 1C must be isosceles, right? So, let's represent AX sub 1 and x sub 1c by n, and then represent b x sub 1 by 3n. Alright. Now, since the triangle AX sub 1c is isosceles, the base angles must measure 30 degrees each. Alright. Now, second statement. Y sub 1 is the point on side AC such that angle x sub 1 y sub 1c is 120 degrees. So let's draw this angle as well. Alright, now we have another triangle. Since angle C is 30 degrees, angle x sub 1 y sub 1c is 120 degrees, the remaining angle here must be 30 degrees. And obviously, angle A x sub 1 y sub 1 is 90 degrees. Now the problem asks us to repeat drawing these angles. So let's draw another one. Let's draw y sub 1 x sub 2c. That's also 120 degrees. And since angle C is 30 degrees, angle x sub 2 y sub 1c must also be 30 degrees since angle y sub 1 x sub 2 is 120 degrees. And of course, this one must be 90 degrees. And this one is 60 degrees. Alright. Before proceeding to the next step, I'll show first one very important tool that we can use to finally solve this problem. If you can recall, there is a very important property of a 30, 60, 90 triangle. This is actually very common. For a 30, 60, 90 triangle, if the hypotenuse is given, then the side that's opposite the 30-degree angle is just half the hypotenuse. Let's say the hypotenuse is c units. This side that's opposite the 30-degree angle must be c over 2 units. And the side that's adjacent to the 30-degree angle is c over 2 times the square root of 3. You can easily prove this one. You can check it yourself. So I'll not be discussing the proof of this. The proof of this can be found in standard textbooks in geometry. Alright. Now what if the side that's adjacent to the 30-degree angle is given? So let's see how this works. So let's say instead of having the hypotenuse given, let's say the adjacent side is given. The side adjacent to the 30-degree angle is given. Let's say the adjacent side is A. So how do you get the side that's opposite the 30-degree angle? Just do the reverse. Just divide A by square root of 3, or equivalently, multiply A by 1 over the square root of 3. Okay? So this side must be A over the square root of 3. Now, The hypotenuse then must be twice this one. So the hypotenuse must be 2a over the square root of 3. The second one is particularly useful for our solution. So we'll use this one later on. Alright? Now, there's another very important information given in the problem. That is ay sub 6 is equal to 728 over 81. Take note that all the y sub i's are on side AC, and y sub 1 up to y sub 5 is to the left of y sub 6 in that order. This means that if we extend the diagram by drawing a couple more angles stated in the problem, then we can break down a y sub 6 into this expression, right? Sum of several segments, um, starting from a y sub 1 up to y sub 5, y sub 6. Alright, let's focus on this part of the diagram. Now, in this part of the diagram, I've extended drawing the angles stated in the problem. Now, let's apply the tool that I have discussed earlier. Now, focus on this triangle. Take note that AX sub 1 is adjacent to angle measuring 30 degrees. So the measure of this side that's opposite the 30-degree angle must be n divided by the square root of 3. Alright? And AY sub 1 must be twice this one. So AY sub 1 is 2n over the square root of 3. Now focus on this triangle. Side x sub 1, y sub 1 is adjacent to the 30-degree angle, right? So to find the side that's opposite this 30-degree angle, we need to multiply this one by 1 over the square root of 3, or equivalently divide this one by the square root of 3. So we have this, right? So I'll not be simplifying this because this will be helpful in identifying patterns later on. Alright, let's apply the property again to this smaller right triangle, and take note this one is adjacent to the 30-degree angle, so the side that's opposite the 30-degree angle must be n over the cube of square root of 3. So again, we multiply this one by 1 over the square root of 3. And of course, y sub 1, y sub 2 is twice this. So we have 2n over the cube of the square root of 3. Now, if you extend the process up to y2, y3, segment y sub 2, y sub 3, you must get 2n over square root of 3 raised to 5. Alright. Now, obviously, if you extend the process up to y sub 6, the expression in the left-hand side of this equation can be turned into this. Okay, so now this expression is in terms of n. Now, if we can find n, then we can easily solve the problem. So let's use this equation. We can factor out 2n, and obviously this one forms a geometric series, right? And there's a well-known formula for the sum of the terms of a geometric sequence. By using that, I'm assuming that you already know that that formula for the sum of the terms of a geometric sequence. So by using that formula, we can simplify the inner expression into this, right? So the common ratio is 1 over 3, right? Now, simplifying this one further, we get this, and by solving for n, we get n equals 3 times the square root of 3. Alright, so now we know that n is equal to 3 square root of 3. Let's focus our attention on this triangle. By using the law of cosine, we can easily create an equation involving ab and n, right? So by using law of cosine, we have ab squared equals n squared plus the square of 3n minus 2n times 3n times the cosine of 60 degrees. Let's simplify first the right hand side. we must get ab squared equals 7n squared. By extracting the square root of both sides, we have ab equals n square root of 7. But we know already that n is equal to 3 square root of 3, so ab must be equal to 3 square root of 3 times the square root of 7, which is equal to 3 square root of 21, right? So, since 21 is already square free, we know that b is 21 and a is equal to 3. And so the value of a plus b must be equal to 24.